Good day, ladies and gents. We're going to be doing Unit 7 on pages 21 and 22, special right triangles and trigonometry. So make sure you guys have your Unit 7 hot topics. And let's just get started. All right, so roof trusses often use right triangles to make a flimsy 2x4 more rigid to hold up the weight of the roof. If the house is 40 feet wide and the roof is an isosceles triangle with a base of 30, how far is it from the bottom edge of the roof to the peak? All right, words, right? Okay, so the key words that we heard so far. I heard that there is an isosceles triangle, right? So isosceles triangle that is 40 wide and the base angles are 30. All right, so let's just make that. So I have an isosceles triangle. So that means that this side and this side are equal. Okay, got that. And it said that it is 40 wide. So all of this is 40. And the base angles, so that would be your elbows, right? Your base elbow, so your elbows are 30 degrees. Okay, awesome. And what are they looking for? They're saying how far from the bottom edge of the roof to the peak. So how far is it from the bottom edge to the peak? All right, so the bottom, and here's the edge of the roof, right, to the peak. So they're looking for this right here. So I'm going to call that X. All right, let's see. Now, how are we supposed to do this? Okay, so if I go straight down, then this over here would be 20, and this over here would be 20. And together they make 40, right? Okay, on top of that, this triangle right here, this right here would be 60 degrees. So basically, if we refocus this, this is 30 degrees, this is 60, this is 90, this is X, and this is 20 degrees. Okay, this should look familiar for a special right triangle right here, right? Okay, so originally this, if we fold it out, right, it's always the fold out is at the 30 degrees and the 90 degrees, and that makes a 60, 60, 60 triangle where the outsides are all equal. So this would be 2x, this would be x, and this would be x radical 3. And a good way to remember that, the missing side is always x radical something. This came from 3 equal sides originally, so that'd be x radical 3. Where versus over here, this is isosceles right triangle, so x and x, the missing side would be x radical something, it's x radical 2. All right, so in this case, where's the fold out going to be? It's always going to be where the 30 and 90 is. So the fold is this way, right? Okay, now step 1, ignore your variables. So this x and our x might be completely different, which in this case they are. So ignore that. Okay, so we know on the outside of this would be 2x, right? And this is real, this is not real. Only half of this is real, so this would be x, and the fold would be x radical 3. All right. So step 1, ignore your variables. Step 2, label, which is what we just did. Step 3, solve for x. Set the side number equal to what you labeled as. So I would say like 5 is equal to x radical 3, x radical 2, and you would just solve, right? So I'm going to give some examples here in case you want to take a picture of that. I'll zoom out a little bit. Okay. So if that's not already on your paper, maybe you want to take a picture. All right, so the side number that they gave us is 20 is equal to, what did I label it as? X radical 3. And now you just solve. I'll zoom in a little more just in case. Have a little trouble seeing that. All right, so we're trying to get x by itself, so we divide radical 3 on both sides. Okay, and then in order to get this by itself, we're not allowed to have a radical in the bottom. So you can copy, paste, erase. So we would copy it, we would paste it on top, and we would leave the number behind. So we would erase the radical that. So copy, paste. When you copy, paste, the thing is still there. It still exists, right? So we're just going to erase the radical. So 20 radical 3 over 3 is equal to x. Okay, and then, okay, now step number, now remember, our red x and our blue x might be completely different. That's why I change colors and all that stuff. All right, so now step 4, plug into the other side. So plug x. So for instance, if I had 2 times x, I would plug in the 2 radical 3. I'd just make it prettier. I would clean it up. All right, so step number 4, plug in. So if I plug it back into here, this would now be 20 radical 3 over 3. If I plug it back into here, I go right back to 20. If I plug it into here, that would be 2 times whatever 20 radical 3 over 3 is, which equals 40 radical 3 over 3. And that's what this turned into. Okay, so, and that is our answer, right? So this was our, so your final step is match up your side lengths. So match up your side lengths to your ignored variables. So this side was our black x, or our blue x. This side is our blue x. This side is also 40 radical 3 over 3. And that's our final answer. Sweet. All right, moving on. All right, so just in case anyone was still needing to take a picture or copy that. All right, so number 2. In sailing, it is not possible to head straight into the wind. In order to get upwind, a sailboat simply sails at an angle to the wind and then turns to sail back toward where it wants to go. I have no idea what's going on. We're just reading. Assume that a boat needs to go needs to directly shoot. I learned how to read at one point. Assume that a boat needs to get directly upwind 6,000 meters. If it sails off at a 45-degree angle to the wind and then it turns back 90 degrees towards the original goal, how far would it sail to get directly upwind 6,000 meters? Okay, so we're like, what just happened? No idea, right? Okay, do we agree that we're going to make a right triangle? That should be at least. Okay, so we have a 45 degree and 90. All right, so we're just going to draw a right triangle. And we know that we're trying to get a certain distance. So look. So we have a right triangle. So basically this was going on. We're trying to go 6,000. Now, but we can't do that. We have to go at a 45-degree angle, then turn right, literally right angle, right? So this is the 90-degree angle. So we're going to go 45 degrees from what we're doing, and then we're going to go this, right? Okay, so now the question is, how far would it have to sail to get directly upwind 6,000 meters? All right, so what the question is, what did we have to, so we're looking for this. How far did we go here? So let's go ahead and find these missing sides. So we're going to call this x and this x. So we have to find both of those. All right, let's do it. All right, so if this is 45 degrees and this is 45 degrees, right? Okay, so step 1, ignore your variables. Step 2, label. So this would be, well, x, and this would be x radical 2. Step 3, solve. Set the side number equal to what you labeled as. And then we solve. So we're going to divide radical 2 on both sides. Okay, we're going to copy, paste, erase, because we can't have a radical in the bottom. So copy the radical, paste it on top, and you leave the number behind. And what are you left with? Oh, look, 6,000 divided by 2, that would be 3,000 radical 2. All right, step number 4, plug in everywhere you saw a red X, we're going to plug in this. So if I plug it back into here, it go right back to 6,000. If I plug it into here, it go 3,000 radical 2, and this will be 3,000 radical 2. Awesome. Okay, now let's actually answer the question. They said basically, how far did we have to drive or, sail? So in this case, we had to do this and this. So really, it would be 3,000 radical 2 plus another 3,000 radical 2. And if you add those together, that'd be 6,000 radical 2. So that would be the final answer. And they want it in simplified radical form, and that's it. So 6,000 radical 2 would be your final answer. Excellent. Number 3. Okay, number 3. An architect is planning a new town square. So I heard square, right? The square has sides that are 20 feet long. All right, so I have a square, and they're 20 feet. I'm just going to label everything, right? A walkway will also cut diagonally. Okay, diagonally. Boom. How far will the walkway be? So we're looking for this. All right, that should be super simple, right? All right, so step one, so this is a right angle. That's 45 degrees and 45 degrees. So this would be x, that'd be x radical 2. All right, so that should be really simple. 20 is equal to x. There's my bubble thought. Everywhere I see a red x, I'm going to plug in 20. So now this would turn into 20 radical 2. So the walkway is 20 radical 2. Super simple. All right. Okay, number 4. The frame for a garage roof is shown to the right. Well, in this case, below. How long is each of the top pieces? So they're looking for this up here, right? So they're looking for this. I want to make that blue. Right. So they're looking for that. And they wanted each one expressed in radical form. Okay, that should be pretty simple, right? So we're just focusing on just that one little part. If all else fails, just redraw it, right? Where now they said that all of this, see how it has that all of that is 120. So really what this is this is 60 and that's 60. So this is 60 degrees, this is 30, this is 90, this is X, and this is 6. And all you have to do is complete that one. All right, so find that X. I'll leave that to you guys. So I'll circle that. Boop. You guys are in charge of number 4. All right, number 5. Ooh, nice. Okay, so on this one, let's plot it. So here's the center. We're going to go 1, -5. There's my A. Okay, now every time we have zeros in the coordinates, write x, y either above or below it. Now, the number is with the x. So that means that the point is on the x-axis. So we're on 5 right here. That's my B. And then x, y. My C is on my y-axis. So that is 4. Okay, and then we're going to use a straight edge. Okay, connect the dots. Okay, and then this was C. All right, so we have this picture, and they want to know what kind of triangle this is. So what you want to do is do the right triangle. We've already talked about this before. So make a right triangle, where this is 1, 2, 3, 4, 5 by 1, 2, 3, 4. So 5 squared plus 4 squared is equal to x squared. So we get 5 squared plus 4 squared. We get 41 is equal to x squared. In order to get this by itself, you're going to square root both sides. I'm just showing a lot more work just in case you forgot how to do it. So it's just a square root of 41 is equal to x. So this distance is the square root of 41. And you would do that to all 3 sides. And once you do that to all 3 sides, you need to compare and figure out what kind of triangle that is, right? And that is from a previous unit. And so if you look at your Unit 4 notes, if you can't remember what kind of triangle it is, now they said based off of the sides and the angles. So if you're basing it off of angles, or sides is the easiest, how many sides were equal, right? And then if you classify them by the angles, how does c squared compare to a squared plus b squared? So simple as that, right? Okay, you should be able to answer that question. So you guys are in charge of that one. So if you can't remember how to do that, look at your Unit 4 Hot Topics. Right? Okay, and then let's go to 22. 22. All right, so on page 22. Okay, now trig. Oh, I love trig. Trig is so good. All right, so just in case you forgot how to do this, zoom out a little bit. All right, so you put, so SOHCAHTOA is an acronym to remember sine of theta, that's what the S stands for, equals opposite over hypotenuse. Cosine of theta, that's what the C stands for, equals adjacent over hypotenuse. And TOA, tan of theta, equals opposite over adjacent. So the steps are, step 1, label HOA. That's your, that is your hypotenuse, your opposite, and adjacent. Step 2, which Which two sides were labeled? Was it the H, the O, or the A? What two of those? Which trig function? So write the trig function equation, one of these right here, and then you plug in what you know, and finally solve. So we're going to solve this. So if you need to take a picture of this because you forgot how to do this, or you haven't updated your notes, so might as well get that squared away. And here are ways on how to do this. So let's see. And then solve. So multiply, switch, or inverse, and I have all of them right there. So if your x was on top, like this, so you would multiply. How do you get rid of the 4? You would multiply it on the other side. So the equation could like this, and you would pop out with this number. If you can't remember how to use the computer calculator or the simplified calculator, this one right here. Okay, if you can't remember how to use this one, I went ahead and wrote down how to type it into the calculator. If you have this calculator, you would just type it in straight like that. Okay, so then have all that. So if you need to take a picture, copy down those notes, do whatever you need to do. Now, how do we label HOA? Well, we're going to get some practice right now. All right, here we go. All right, so you put your finger on the 90-degree angle. And if you, just in case you don't remember, so you put your finger on the 90-degree angle first, and you see how we're touching these two sides? So the one side you're not touching would be your H. So the opposite of the 90 degrees would be your H. Then you put your finger on the theta, or whatever angle they gave to you. So in this case, it's at 13. And the one side you're not touching is your O. So this would be O. See how I'm touching this side and this side? This side would be O. And the leftover would be A. So HOA. To get tricky with it, you got to find HO first, and then you can get yourself some A. All right, so, and this right here would be A. All right, now what two sides were labeled? We have, so O doesn't have anything with it, right? But H has something with it, and A has something with it. So we have H and A. Now, what trig function uses H and A? So, ka, toa. Now, which one has an H and A in it? So not this one, that right here, H and A right there. So we're going to use this. So let's write out the equation. That stands for cos of theta equals A over H. Now plug in what you know. All right, so cos of, what was the theta? What was the angle? That's 13 equals A, which is X, over H, which is 50. So this could be my answer. But in this case, they said, hey, round to nearest tenth, so we have to keep going. All right, now is X on the top, the bottom, or with the trig? It's on the top. So that means that we want to get rid of that 50. So X is on the top, so we're happy, right? So it's on the top, we're happy, we're going to multiply, or take that 4, multiply on this side. So in this case, take that 50, multiply on the other side, and that'd be 50 times your cos of 13. All right, now how do I type it in this calculator? I would type it in just straight off, and you make sure that you're in degrees. All right, so that'd be 50 cos of 13. And I get this answer. So that'd be 48 point, and they said to nearest tenth, so 0.7. Now, how do you type it in this calculator? All right, you basically have to type it in backwards. So first of all, make sure you're in degrees. All right, we would do 13 first, and we're going to cosine that. And then we're going to times 50 equals. And now we got the same answer. Sweet. All right, and we got 48.7. All right, let's go ahead and move down to number 2. All right, number 2. A rope is tied to the bottom of the hot air balloon. The altitude is 50. All right, so this is 50. And the rope, so here's the rope, is 75. What is the angle? So we want to find that angle. All right, I'm going to zoom in. All right, just follow the steps. Don't overthink it. So label HOA. So put your finger on the 90. The one side you're not touching is H. Put your finger on the theta. That's the angle. The one side you're not touching is O, and the leftover side would be A. Now, what two sides are labeled? H, O, or A? H and O. Now, what trig function uses H and O? Now, I like to write this out. So, katoa, which has H and O in it. H and O would be so. Write out the equation. Sine of theta equals O over H. Sine of theta, I don't know what that is, so I can either leave the theta or I can call it X. And that'll be 50 over 75. Okay, now is the x on the top, the bottom, or with the trig? It's with the trig. Now the question is, how do we get rid of the trig? So if it's with the trig, we're going to inverse. So we're trying to get rid of the, in this case, we're trying to get rid of the tan. So we would do tan inverse on the other side. All right, so in this case, we're trying to get rid of the sine. So x equals sine inverse of 50 over 75. Okay, now we're going to type that in the calculator. All right, so I'll zoom out. Okay, so now to get the sine inverse, see how it's yellow? To get to the yellow stuff, I have to push the yellow button first. So second sine, and now it's the sine inverse of 50 divided by 75 equals. And I get this answer. It'll be your job to write that down. Okay, that's one way how to do it. If you had this other calculator, okay, so to do this calculator, what you'd have to do is you have to do the fraction first, equals, and then you would do second sine or tan or whatever you need to do, depending on the situation. So in this case, I would need to do 50 divided by 75, and I have to push equals or it's not going to work. Equals. Now I'm going to do sine inverse of this fraction. So second sine, and then you stop because I already used the equal sign, and that would be the same answer. So it's your job just to write that down. So right there. So I went ahead and put it in here. You just need to write down the answer. Sweet. All right, number 3. From a plane flying due east. So we're going east, 265 above the sea level. All right. So that means this right here. So above sea level, right? So 265 is above sea level. Angle of depression is 35 and 25. So one of these angles now, here's the thing, angle of elevation and depression. What's awesome about those is no matter what you do, it's always going to end up in the bottom corner. If I ever say elevation or depression, they always end up down here at the bottom no matter what you do. So why is that? I don't think you care, but I'll just show you right now. So if I had, you always start with the horizontal line. I'm just explaining. So if I had this, so if I have the angle of depression, if I make my z my ultra interior angle, it still ended up right here. If I had angle of elevation, see, I always have to start with the horizontal line, and it's the angle that goes up. So you see, no matter what, it's always going to land in this bottom corner no matter what. If I say elevation or depression, it's always that bottom corner. Might as well just throw it in there. Okay, so the two angles that I have are 35 and 25. So the fatter angle is 35. So this is the fatter one. So this is be 35 degrees. And the skinnier one would be 25 degrees. Now, if you get those backwards, it's not going to hurt you too much. The picture will be off, but it'll be okay. All right, so what we're going to do is, what we're doing is separating the two triangles. So we have this triangle right here, where this is 265, where this is 35. We have another one where this is 265 and this is 25. And what we want to do is we're trying to find this right here. That's the whole goal. So we're going to call this x and this x. What we're going to do is we're going to do the trig of both of those and then subtract the two numbers. That's it. And if you get a negative number, that just means you did these two backwards. Not that big of a deal. Just give me the positive version of that. So do the 2 trig. So label HOA. What trig function you need to get? So that would be tan. So tan of theta equals O over A. That'd be tan of 35 equals 265 over x. Now, how do I get x by itself? Well, see how the x is on the bottom? We're sad. So we're going to switch these two. We're going to totally switch these. So that'd be x equals 265 divided by tan 35. All right, let's type that in the calculator. All right, so I'll zoom out a little bit. All right, so we're going to do 265 divided by tan of 35. And we get this big long decimal. Now write out the whole entire decimal. We're not rounding yet. So 378.4592218. Now here's the awesome thing. Both of these are basically the same thing. They just have a different angle. So basically, just to save yourself some time, just skip down to here. This would be x equals 265 over tan of 25 this time. And you get that decimal. And I'll leave that to you guys. Now, what are we going to do with those two numbers? We're going to subtract them. So subtract those two numbers. And then you are going to you're going to round. Now they said usually I'll have like to the nearest oops. It'll say to the nearest whatever. I'm pretty sure I have that on the form. But go ahead and just give me to the nearest whole number if I didn't already say it. Okay, so we're going to find this one. We're going to subtract the two numbers, and you give me to the nearest whole number. So I at least started you off on that one. Okay, and we're on number 4. All right, you are 55 feet from a tree. All right, so there is a tree, right? So there's a tree, there's the ground, and here's you. Okay, you are 55 feet away from this tree. The angle of elevation from your eyes, so here are your eyes, and you're looking at the top of the tree. Now your eyes are 4.5 off the ground. So from here to here is 4.5. And then, and the angle to the top of the tree, so the angle that we're looking, angle of elevation, so it's always this bottom corner right here, this 61 degrees. Okay, how, to the nearest foot, how tall is the tree? So I'm looking for this height right here, right? Now, on this triangle, we're off the ground at 4.5. So we're going to find x, but then we have to add 4.5 to the end of it. Now, this is just the way I do it. I don't want to have to like put x minus 4.5 in here. So just find x and just remember to add 4.5 when you're done. So do the trig, and then whatever you get for x, this right here would be x plus 4.5. Whatever you get for x, just add 4.5, and that will give you the full height of the tree. So I'll leave you guys to that one. I'll start you off on the picture. Okay, on number 5, a roof is shaped like an isosceles triangle. So that means that these two sides are equal, because see the elbows are equal? The slope of the roof is 24 degrees with the horizontal side, and the altitude is 3.5. Determine the width to the nearest meter. So we're looking for all of this. That's it. So what we're going to do is, so this be x, right? And this is the width. So once you find these two x's, or in case you find this one x, just multiply. And so let's say that there's 7. It's not. But let's say that was 7. This would also be 7, so the whole distance would be 14. It's not, but you can figure this out. So you're going to do the trig. So just take out the one little triangle here, where this is 24 and this is 3.5. And we're going to do SOHCAHTOA, right? Where this is x. All right, so label H, O, and A. What trig function are you going to guys use? So this is O and A, so that's TOA, so tan of theta equals O over A. Tan of 24 equals 3.5 over x. Okay, and then you just keep solving for that, and then when you're done, do not round yet, right? You have the big long decimal. Then you're gonna multiply by 2, and that will give you your width. Net after that, then you would round, and that's it. You guys have a great and wonderful day.